This video is starting our look at something called a matrix. So a matrix is a rectangular arrangement of numbers in rows and columns, and we talked about them in terms of their dimensions, m by n, which means rows by columns. Row goes across, columns go down. So I'm going to kind of talk about these in terms of, if I say row 1, column 1, so I'm going to call this row 1, row 2, column 1, and then 2 and 3. My writing is too big to fit it in there. So if I said row 1, column 2, my entry would be 3 for that space. Okay, if I said row 2, column 1, my entry would be 0. Okay, so we talk about them by their location. So we can add them, we can subtract them, we can multiply, and so on. They have to have special properties and everything in order to be able to do that. And we want to think about these matrices as representing each location might represent something in particular. So, for instance, the 4 in this one up here might represent the number of bolts I have on my shelf. The 3 might represent the number of screws that I have, and and so on and so forth. So they might represent something within my business or whatever it is. So we're going to start looking at them out of context and work our way up to looking at them in context. So we're going to start with adding. In order to add and subtract matrices, they must have, again, they must have the same dimensions. Okay, because we're going to add or subtract corresponding pieces. So if they're not the same dimensions, not all of the locations in the first matrix is going to correspond with something in the second. So let's look at example 1 to start. Both of these are what we would call a 2 by 2 because they have 2 rows across and 2 columns down. So they should have a corresponding piece for each entry. So I'm going to do the top left. Let's see if I can write a little better here. Top left's 2 plus 4. Okay, and then I'm going to do the top right. Negative 3 plus negative 1. And I'm going to do the bottom left. 5 plus negative 6 and 8 plus 0. So all together I have 6, negative 4, negative 1, and 8. So I end up with a 2 by 2 matrix. Okay, I want you to try this second one. Remember to combine, and in this case you're going to subtract. So I'll do the first entry for you. 7 minus 2. Top left is going to give me 5. So now you need to do the top middle, and so on and so forth. Finish off this matrix. Once you finish that one, now if I look at C, notice I have a 2 rows by 3 columns. And here I've got 3 rows by 2 columns. I cannot subtract because they're not the same dimensions. Alright, we can also multiply these by a scalar, meaning a number on the outside that I'm going to multiply each entry within the matrix by. So for instance, if I have in this case a 3 by 2, each of these 6 entries I'm going to multiply by negative 2 to result with negative 8, 2, negative 2, 0, negative 4, and negative 14. I can combine addition and subtraction with scalar multiplication. So what I'm going to do first for B is multiply all of the first matrix by 5 and then subtract multiplying all of the second matrix by 3. So I'm going to do the first, multiply each of them through by 5, 5, or times 2 is 10, 5 times negative 1 is negative 5, 5 times 3 is 15, 5 times 0 is 0. Now I want you to multiply the 3 through to each of these 4, and then subtract these two matrices. Again, you're going to get out a 2 by 2 because that's what I started with. Okay, so we have the associative property, commutative, distributive, and all of that good stuff. Associative means that it doesn't really matter how I group them to add them together. I can add the first two together, and then whatever I get for that, add the third one, or I can group the B and C together and add that to the first one. Okay, so addition, it doesn't matter what order I add in, but remember subtraction, it does matter what order I add in. So if I look at example 3, of all of these different properties that I have, I see I can treat this as pulling out a 5 and then doing the addition. So I'm going to pull out 5 from this and then treat it with the addition. So I've got negative 7 plus 3 is negative 4. 4 plus 0 is 4. 0 plus 2 is 2. 3 plus 4 is 7. So now I can multiply the 5 through and get negative 20, positive 20, 10, and 35. Okay, so then order of operations still applies as well. I'm going to do, remember, it's multiplication, or parentheses, exponents, multiplication and division in the order that you see them left to right, and then addition, subtraction in the order you see left to right. So I've got addition, so I'm going to do that first, and then whatever answer I get from that, then I'm going to add or subtract the 5, negative 6, negative 13, and 6 from it. So if I do that, I'm going to have 0 plus 2 is 2, 9 plus 11 is 20, 10 plus negative 3 is 7, negative 4 plus 4 is 0. And I'm going to subtract from that the 5, negative 6, negative 13, and 6. So if I do that, I get out 2 minus 5 is negative 3. 20 minus negative 6 is 26. 7 minus negative 13 is 20, and 0 minus 6 is negative 6. Ultimately, what our goal is to use matrices to solve systems of equations. So I'm going to have them set up here very basically. We'll look at how I do just basic algebra with them, and then grow to the point where we're using our calculator to solve a system for us. So first, if at any point I have an equation set up here where I have x's and so on, corresponding pieces in this case are going to equal each other. So if I have it set up where I have a matrix equals another matrix, corresponding pieces are equal to each other. So the top left should be equal, the top right in this case, the bottom left, and the bottom right. So if I use that idea in my example for part A, then what that'll give me is that first I'm going to treat this, the top portion that I have, okay, if I look at corresponding pieces, the 5x plus the 3 must equal the negative 21 if I multiply it by 3. So I've got 3 times 5x plus 3 must equal negative 21. That 3 times only applies to the left side of the equal sign. So you can either multiply the 3 through by distributing, or I can just immediately get rid of it and divide both sides by 3, so that leaves me with 5x plus 3 equals negative 7. And then when I solve for x, I'm going to subtract 3 from both sides, which gives me negative 10, divide by 5, and I get x equals negative 2. Now if I solve for y, I see y in the bottom left, so I'm going to put the left bottom left pieces together, and I still have 3 times. So I've got 3 times the bottom left, or bottom right, excuse me. Bottom right, negative 4 plus negative y, which is ultimately minus y, is equal to negative 24. You have to be very cognizant about what is in between the matrices. So again, I can either carry the 3 through, or I can just go ahead and divide both sides by 3, which I think is what I'm going to do. So it's going to give me negative 4 minus y is equal to negative 8. Add the 4 to both sides, and then divide by negative 1. So I get x is negative 2, and I get y equals 4 for this particular one. Okay, I want you to try B. Once you get finished with B, okay, then C and D are set up to look a little bit more like systems of equations. We're going to get, it'll alter its look even yet still from section to section, but this is how we're going to start with it. So I can treat this just like a regular system. I see that if I want to do elimination, I can multiply the top by 5 and the bottom by 2, and then solve accordingly. So it's going to give me 10x minus 20y is equal to negative 20, and 10x minus 6y is equal to 36. So if I subtract these, I'm going to get negative 14y is equal to negative 56, so y is equal to 4. And then if I plug that back into one of these, so I'm going to say 2x minus 4 times 4 is equal to negative 4. So I get 2x minus 16, so I'm going to add the 16 over to get 12. So I get x equals 6. So my point, if this were a system of equation, the point where these intersect is 6, 4. I want you to try D.